Hello, this is question 7 from the 2019 MAT. You are given two identical black boxes, each with an n-digit display, each with two buttons marked A and B. Button A resets the display to 0. Button B updates the display using a complex, unknown but fixed function f, so that pressing button A, then repeatedly pressing button B displays a fixed sequence. x0 is 0, x1 is the function with x0 pumped into it, and then so on. And that's the same for both boxes, right? So in general, x subscript I is f superscript I of 0, where f superscript I denotes applying function f repeatedly I times. Yeah, we always use that notation. You have no pencil and paper. Display has too many digits for you to remember, more than a few display values. You can compare the displays on the two boxes, see if they're equal. You can count the number of times you press each button. Okay. Explain briefly why there must exist integers I, j, with I greater than or equal to 0, less than j, such that xi equals xj. So just a quick reminder of what these are then. So xi is the number displayed on the box after you've pressed button B I times. And then similarly for xj. So eventually, so we're saying if we press button B I times, and we press on one box after we've reset it, and then on the other box after it's been reset, we press the button J times, we get the same number on the display. And we have to explain why there must be cases where we will get the same number on the display. Right, okay, that's gonna, well, there's only so many numbers we can show. I mean, we can't just show everything forever. I mean, it is an n-digit display, so at least that gives us something to come back to. So let's go off that then. So we can say it's got an n-digit display. Therefore, a limited number of numbers, that can be displayed. So therefore, if sequence continues forever, which it does, forever, let's just say in brackets, which it does, we must eventually get a duplicate. Eventually get a duplicate number. Cool, okay. Show that if xi equals xj, then xi plus s equals xj plus s for any s is greater than or equal to 0. Right, okay. Right, that seems obviously true, because if we've got to the same number and then we go s presses from those, it doesn't matter how we got to that number, we must have the same number that comes afterwards. But how do we show that? How do we actually put that into English or maths or something like that? You know, because yeah, if these things are the same and we're just running a function off of the same starting numbers, they're just going to stay in sync, aren't they? So it doesn't matter, provided we're doing the same number of presses from those points, they're going to keep staying the same. So I could write that in English, but I'm thinking of maybe trying using their notation here. Maybe this is going to be the thing that we want. So if I say xi plus s, so that is going to be, well, we're taking xi and we're pressing s times from there. So that will be fs of xi. And that must be equal to, no, the xi is the same as xj. So yeah, fs of xj. And that is equal to x of j plus s. Okay, so yeah, the notation comes out a treat on that one. Part 3. Let m be the smallest number such that xm appears more than once in the sequence. Right, more than, does that mean the whole sequence or the sequence we've seen? Or is that exactly the same thing? I'll come back to that. Let p be greater than 0. Be the smallest number such that xm equals xm plus p. Show that if I is greater than or equal to m, k is greater than or equal to 0, then xi plus kp equals xi. Again, that seems obvious. I think the show is going to be difficult, maybe. Let's go back to that first part of the question. The thing that's bothering me is, right, so when it's saying the smallest number or the first xm that appears more than once in the sequence. So does that mean we're looking at the whole sequence and then we say, okay, that one and that one are the same, and that's the first time we got a duplicate, so that is xm? Or is it the sequence has been revealed to us? Oh, but that would be the same thing, isn't it? Because if it was a sequence that was revealed to us, when we reveal the second one, xm will default back to the first one. So actually it doesn't make any difference, right? So I can park that concern. Show that, right, so I is greater than or equal to m. I mean, again, this seems pretty obvious. So what we're saying here is we start at x0, we go up to xm, which means we pressed m times. Then we go up to xm plus p, so we pressed another p times. So we're saying, right, these are now the same. That's the first duplicate that we've got. And then every time we do another p, obviously we're getting back to the same place, because if we've got the same number here, this xm and xm plus p are the same, then doing another p presses is going to take us back to that same number at xm plus 2p. So how do I then turn this? We will need to talk about i's here. We need to talk about i's. So right, so we need to use, we can use this, that's going to be useful because that's in the same format. I need to change it over to i's. I's are greater than or equal to m. I's are greater than or equal to m. Is this anything to do with the previous part of the question? Yeah, not really. I don't think. Not really. So say we were saying that I was equal to m plus some amount. So, well, we've had it. Let's go t. So if I is m plus t, then we can say, what else can we say? If so we know that where t is greater than or equal to 0, so that's fine, which means we can say that xi is equal to xi. Oh, but this is, I'm just writing down what it is we actually want to show. I'm not sure that's what we want, is it? Well, m plus, actually the m plus t, let's go off the m plus t with that. And then, so xm plus t would be equal to xm plus t plus p. We know that. Yeah, so that's used this equation. And then I can replace those with i's. And I haven't just jumped straight to the answer. So xi would be equal to xi plus p. And that is going to repeat. Well, we can actually say then on this previous one, we could extend that to say, so xm equals xm plus p leads to xm is equal to xm plus kp, and then plug that into there and say that xi equals xi plus kp. Yeah, so we can go with that. Let's just do that again. Let's write this. So I'm using this equation instead. So here I'd put a k, and then there I'd put a k, and then that'll come out just fine then. And then I don't really need, so let's take this bit here, these two lines, and just stick them up there, and then we'll be okay. Right, okay, again, fiddly. I mean, it's kind of obvious that that's what's happening when you're looping through these numbers, but doing a show that isn't that trivial off of the back of some of these. But I need a new sheet now. There's my mouse disappeared to. Here we go. And part 4. Given integers I, j, I is greater than or equal to 0, less than j. Show that xi equals xj if and only if, right, I is greater than or equal to m, so we've gone past that first one that's going to duplicate. Well, that kind of makes sense. And j minus I is a multiple of p. Right, this sounds, we've got a hint. Let R be the remainder on dividing j minus I by p, and argue that R is 0. I'm not sure that's helping me much. Right, I'm gonna draw another picture on this. So we're saying then that we're starting from x0 and we're going I times up to xi. xm is somewhere around here. We've gone past xm, or at least we've reached xm at a minimum. Then we go up to xj. So that means we must have done j minus I presses to get to there. And then these things are the same. Right, so I can just drop this into the previous part of the question, can't I? I can say, so we've got xi equals xj, and we've got the xi plus kp equals xi. So xj equals xi plus kp. So j equals I plus kp. So what am I trying to show? J minus I is a multiple of P. Oh, there we go. J minus I equals KP. Right, I don't know, is that the same as their hint? I mean, the hint seems more confusing than the question. Anyway, that's worked out fine. I'll just leave it at that. It's not often that the hint isn't the way to go, but maybe, I don't know, maybe you'll see more looking at the hint than I've seen looking at the hint, but it's not helped me very much. Part 5, you conduct an experiment where after resetting both boxes, you repeatedly press button B once on one box and button B twice on the other box and compare the displays, thus determining the smallest number, u greater than 0, such that x of u is x of 2u. Okay, what relates the value of u to the unknown values m and p? Okay, so, well, we know bare minimum on this, u has got to be greater than or equal to m. So we've got that. We also know that, so the difference between these is u, so that must be a multiple of p, because we've got j minus I, which is u. So our j minus I in inverted commas, actually j minus I equals kp in inverted commas, means that we've got 2u minus u equals kp. So u equals kp. So we've got u is a multiple of p. U is greater than or equal to m, and it's going to be the first one past it, isn't it? Because we can't go multiple times past it. We're going to have some, if that's our m and this is our u, we're going up in blocks of p. It's going to be, it's going to be the first one, isn't it? It's going to be the first multiple of p, which is greater than or equal to m. So u is the it's the smallest multiple of p that is greater than or equal to m. Right, all right, I've already filled up another sheet. Hopefully this will be the last one I need. Part 6, there's a lot of parts to this question. Once u is known, what experiment would you perform to determine the value of m? Right. So how on earth are we going to do this then? So u is known. What experiment would you perform to determine the value of m? So we know we're going to get duplicates at u and 2u. But do we just do them that way? How is it? If we count up, we're just getting a multiple of p that's greater than m. So how is this helping? We need to get m. So right, let's go with another picture then. So we're going from 0 up to xm. So that's m presses. And we know that's the first time we get a duplicate. And the first time we get a duplicate, what do we know? How am I fitting u into this? How am I fitting? U is a multiple of p. So if we've done u presses onto there, we go to xm plus u, these things are going to be the same. So we know that. So we need to get them u presses apart. Yeah, and then we can start counting up. Yeah, if we got them u presses apart. Right, okay, so reset both boxes. That's step 1. Step 2 would be press B U times on one box. So now they're U apart. Now we just keep pressing B on both boxes until we get a duplicate. Press B, well, it would be M times on both boxes until well, let's I don't know, I mean, I've said M times, it's kind of preempting the answer. So we press B, so and count presses, I think is what we really want to say. So press B and count presses on both boxes until we get a duplicate. And the count equals M. Right, because that will be our first duplicate up, because we're starting from 0 on one of the boxes. We're going up M times is what it's going to be. And that will give us a duplicate because the other one is U presses ahead, which is a multiple of P. Yeah, okay. Right, that was a little bit sneaky, that one. And then last part, once U and M are known, what experiment would tell you the value of P? Right, well, we don't really need U, do we? I mean, you just get to M and then you press both. So yeah, I mean, that one, you don't need U at all in that, do you? So we'll reset both boxes, then press B M times on one box. Okay, and then we will, I mean, we can't, I mean, it says, I mean, I'm just coming back here. You have no pencil and paper. Displays too many digits for you to remember more than a few display values. Well, you could just remember that value and then press it. I mean, it says we can remember display values. I mean, either way, we're either going to be, well, let's just stick with press B and count presses. I mean, we're doing the same thing until we get a duplicate again, is what it's going to be, isn't it? Is that going to be right? Because we'd be, actually, no, we don't even need to, no, I'm doing this the wrong way around, don't we? We're getting them both to the same. We're getting both to M. So press B M times on both boxes. Press B and count presses on one box until duplicate. Yeah. And then the count equals P. Right. So yeah, reset them both. Both get them up to that XM, and then just keep pressing B on one of the boxes until that display number comes back round again. And then we got P. Right, okay, well, we've finally got to the end of that. That was a difficult question, I would say. There were a lot of parts. None of them were particularly easy, except maybe the first part. I don't know, but all of them were tricky because they were either, they seemed obviously true, but you've got the difficulty of actually showing that they're true, or they were actually quite difficult questions. So I would say that was a particularly tough question 7, especially compared to some of the other question 7s that they've been in the past. But that one, I think, I mean, this has probably taken a long time. I don't know what the clock is on this, but I think it's going to be a long one. But still, that's rounded off 2019 Matt. Anyway, I think it was yeah, quite an interesting paper, tougher than some of the other years. And onwards to 2020.